Hi, this is Julia Bell. Welcome to ccna1, Chapter 3, Part 2. We're talking about rules. Rules are used to facilitate communication and make the transfer of data easier from point A to point B. Rules that govern communications, for instance, a protocol suite, is used to use a common language. For example, a protocol suite uses a common language, you wait your turn, and then it signals when it's finished. Network protocols. How the message is formatted or structured, the process by which networking devices share that information about pathways with other networks, how and when error and system messages are passed between devices, the setup and termination of data transfer sessions. These are all determined by the network protocols. Interaction of protocols. We'll talk about 4 here. The application protocol. An example would be HTTP. Hypertext Transfer Protocol. That's a protocol that governs the way a web server and a web client interact. TCP, Transport Protocol, is the transport protocol that manages the individual conversations between web servers and clients. Any one web server can have hundreds, thousands, maybe even millions of individual conversations going on at any one moment in time. HTTP relies on other protocols to govern how the messages are transported between the client, which is your user, and the server, which would be like our web server. TCP controls the size and rate of the messages exchanged between server and client, and TCP also segments messages and manages the segments into individual conversations between the web server and the web client. IP, Internet Protocol. It's responsible for taking the formatted segments from TCP, encapsulating them into packets, assigning them appropriate addresses, and delivering them across the best path to the destination host. Network access protocols, for instance, data link and physical layers, describe 2 primary functions: communication over a data link and physical transmission of data on the network media. An example of a network access protocol would be Ethernet. Protocol suites and industry standards. The one on the left is one that you'll become very familiar with. This is the TCP/IP protocol suite. When you think of layer 7, HTTP, layer 7 is the end user layer where it's presented in a format a human can see and understand. DNS, domain name server. Again, when I go to Google, I type in google.com. I don't type in whatever their physical address is, their IP4 or IP6 address. Most people couldn't remember that. DHCP is another one that's going to give out individual IP addresses at your location. FTP file transfer protocol. When you go down to layer 4, transport, the TCP and UDP. UDP is the unreliable one. A lot more about that in future chapters. The third layer, which is your network layer, IP version 4 and 6 and ICMP 4 and 6. Layer 2 would be your data link and then your physical. Here you think of Ethernet, point-to-point, frame relay, ATM, and your WLANs. Here's ISO standards. Here are AppleTalk standards. And more you'll see that all the standards are merging in this direction. For TCP/IP, we've decided on a common standard. AppleTalk was very prevalent. Novell was also very prevalent, and there were several other standards that were prevalent. When I started networking, we had to know all the standards and to try to figure out how they would interoperate. Some days not so well. Creation of the internet and development of TCP/IP, transmitted on an SDS Sigma 7 mainframe, University of California, Los Angeles, to another mainframe in Stanford. Colleges were among the first, and the military immediately, of course, grabbed hold of that. I think the second install was AlohaNet from the University of Hawaii. But 1969, Stanford and UCLA were the first. TCP/IP protocol suite and communication. Notice the layers here, your application layer. You think of these as layer 7, 6, and 5. 7 being the closest to the end user. DNS, BootTP, here's DHCP, email protocols, simple mail, POP, IMAP, file transfers, trivial means no error checking. Web, we're very familiar with that one. and then several other ones. Further in the CCNA 1 and 2, we'll talk about these routing protocols that operate at the internet layer, or layer 3. Now the TCP layer, which is transport layer, here's the protocol that operates at that layer. The correct order of a protocol stack for web pages request from the client to server web would be HTTP, we start here, then we go to TCP, then we would go to IP, which should be somewhere in here, and then we would go to Ethernet. So if you're talking about communication from a web server or from an end user to a web server, it'd be HTTP, then you would go down to TCP, then the next one would be IP, and then finally out on the Ethernet. So that's the order of that communication. Protocol suite and communication, this is actually in your curriculum and it's a great matching exercise. I highly recommend you do this. Open standards, Internet Society, the Internet Architecture Board, the IETF. We do have several representatives in East Tennessee on the IEEE, for instance, and the IETF. IEEE is the Institute of Electrical and Electronic Engineers. We also have the International Organization for Standards, or the ISO. Here's some more of those. For instance, when you talk about the ISOC, the Internet Society, here's your architecture board, and then it breaks it further out to Internet Engineering Task Force and their steering group, and then the working groups. Same thing on this side of the house, the Internet Research Task Force, their steering group, and then the different research groups that they have that look into the standards and try to come up with protocols and standards that will work to make equipment interoperable for all of us. One thing when you're talking about standards, and especially open standards, the opposite of open would be proprietary. Now, proprietary protocols are developed by organizations who have control over the definition and operation of those protocols. So that's a good thing to remember. Right now I'm talking about open standards that interoperate between different brands and different equipment manufacturers. But a proprietary would be designed by a group to use only a certain brand of equipment. An example of open standards would be on the other side of the house, client, host, and server running different operating systems that can fully exchange data. That's a great thing. Standards organization for IEEE, 38 societies, 130 journals, 1,300 conferences a year, 1,300 standards, 400,000 members. This is one big organization. But the IEEE standard for connecting wireless by different manufacturers is the last one, IEEE 802.11. Yes. And here are the working group and studies for the 802. 802.11 would be wireless. 802.15 wireless personal WAN, PWAN. Here is 802.16 broadband wireless. Some of those to think about. But here are two of them that I definitely want you to remember. 802.3 Ethernet and 802.11 wireless. This is the end of part 2.